Hello guys, so in this video we will learn how to measure the grain size distribution graph using ImageJ. So grain size distribution is very good and much better than average grain size or grain size measured by the intercept method. So this is authenticated method which is used for the journal publication and thesis. So the final graph looks like this. So in order to measure the grain size distribution, we have to measure the grain size. So these are the grains. In fact, we have to measure their area. And for area, we will use the ImageJ software. And then we will use the origin to measure their diameter. So we know that area, these looks like circle, though they are not exactly circle, but the formula for area of circle is equal to pi r square. R is the radius and here is equal to diameter divided by 2. So if we solve this equation for d, we will get diameter is equal to 2 square root area over pi. So we will use this formula to calculate the grain size diameter. So let's get started. So first you have to use the ImageJ software. So if you have already installed the ImageJ, you can just open and click on the file. First you have to open the SEM image having the grains. So let's choose one, this. Okay, then you can see the images in RGB. So first you have to convert into the type 8-bit so that we can do some measurements. And here you can see this is a 5 micron. This is the scale bar. So first we have to set the scale. So choose a line tool and press Ctrl and scroll the mouse to make the image slightly large. Okay, you can press Ctrl and scroll up or down to increase or decrease the image. So then choose the line tool and press the shift key on the keyboard and then left click and move the line. It will be straight line and then release. If you don't press the shift, it will not be straight line. So then you have to analyze set scale. So what is the distance of this line is 5 micron. So known distance you have to insert 5 and here you have to insert micrometer. Okay, this is micrometer. Then click OK. Okay, perfect. Now what we will do, we will choose an area instead of whole image where we can measure the grain area first. So choose the rectangular tool and let's choose this area. Okay, and I want to use this area for measurement, so I will click on image and duplicate or crop. Let's duplicate. Okay, so now this image will be used for the measurement. Okay, good. And then make sure it's 8-bit and then go to the image, adjust and click threshold. Okay, now you can see there are only two colors, one is red and one is black, so we can easily distinguish grains. So if the grains are very small, but in this image the grains edges are a bit thick, so we will keep the like up to this. So the red is grain and the black is just boundaries. In this case, in this image, the boundaries are pretty thick because somebody have etched the surface too much. But most of the image are different, or slightly their edges are very sharp, or boundaries are very thin instead of thick. Okay, this is perfect. Then apply. Okay, now they are turned into black and white color, and then is close. Now you have to go to the analyze and set measurement. So what you want to measure from this graph? First is area and then ferrite diameter. So if these boxes are unchecked, you have to check them, then click OK. Okay, then again go to analyze and analyze particles. So you have to set the range. Micron is from 0 to infinity. You can, they are not infinity, they are maximum 10 micron. And then this is a circularity, this is a 0 to 1, and then you have to choose the overlays mask, and then you need to check these boxes to get the results, then click OK. Now what we have, this is the summary which shows the total area, average size, percentage area, etc. Just ignore this. You have to check these results. So which shows the area of the grains here. You can see these colored grains are counted towards the area calculation. The white are not counted towards the calculations. So we got the area. So as I told you, if we have area, then we can measure the grain size or grain diameter using this equation. So as area we have already measured, so we will use these equations. So first we have to copy this data, click on edit, select all, again edit, copy. Okay, then open your origin, open a book sheet and click here and Control V. Yeah, so you can see this is the area. In the second column is area, that's why I have chosen the area. So now we will use this equations. As I told you, first we will measure the area over pi, then we will take square root, then in next step we will multiply it by 2, then we will get d. So let's add a column. Yeah, and we can first we will measure the area over pi, then square root of this area over pi, then multiplied by 2. So I have already put this information here, so let's copy and I will insert here. Okay, okay, perfect. And for area over pi, we need to area divided by 2. So we can use this functions. Actually they are automatically appeared, I will tell you manually. So you can click here, or just click this and click column B divided by 3.8 3.14 and then click enter. Yeah, you got the area column B over pi. Yeah, and then you can also choose the another way. One is set column value. We need to take the square root. So functions, math, and choose the square root of column I. So we have to choose a column I. Apply. Okay, so we got the value. So we have calculated area over pi and then square root. Now we just multiplied by 2. Then you can use the same way. 2 multiplied by, these are two different ways, you can use any one. Column J, sorry, you have to measure the column. Yeah, J. Yeah, so this is 2 multiplied by square root area over pi. This is column J. So we got the area over pi, square root, area over pi here, area we have here. square root in this column, and then multiplied by 2 this column, and we get the diameter, and it's in micron because we set the scale in micron. So that's it. Just click on this, go to the plot, and you can choose distribution graph or histogram like this. So this distribution is not good as in this image because this belongs to different SEM image. So this is the count, and this is the grain size. Micrometer, and these are like sigma and mu value. So this we can delete. Let's choose another type of graph. Maybe distribution is much better. Histogram. Yeah. So most of the grain here, let's choose grain size micro. For micro, you can click alpha, beta, and press M, and then uncheck this, and again press M to write the micrometer. Yeah, you can change this scale from 0 to maybe 2, so it will be looks like this. And here you can see most of this is grain size distribution graph, which is better than the intercept method. So most of the grains are in the range of less than 0.2 micron, and some of them are like here. So if you plot the distribution graph with the mean, then you can also get the mean values. So today we learned how to get the grain size distribution graph using ImageJ, and then use this formula and draw the graph using origin. If you have any questions or comments, please leave a comment. Thank you very much.